Because you're mine, I walk the line.
Recall that if you want to write the equation of a circle, we have a standardized form for that. The standard form of the equation of a circle is given here. A circle that has center hk and radius r is given by this equation. So if you're solving it in this case, the h and the k values come from this value of the center, and 3 rad 7 is my radius. So to figure out how to plug these into my equation, I'm going to need to find the radius squared. So I'll take 3 rad 7 squared, which would be 9 times 7 or 63, and then I'll plug in my corresponding values to the center of my circle. So it'll be x minus 4 and y plus 5. Recall that the signs of the values in this form are opposite that of the center, and my radius is squared, so I have 63. Now the two pieces of information that strictly determine a circle are the same two pieces of information we used to plug into this equation. It's the center and the radius. The center gives me the position of the circle, and the radius gives me the size of the circle, or how far away each of those points on that circle are from that center. And recall that these values x and y represent the coordinates of all of the points that make up the curve that makes up this circle. So now, to think about how to write the equation of a line, we're going to need to think about what two pieces of information strictly determine a line. Well, for any line, it can be easily described by its position and its direction. And the two things that determine the position and direction, a position can be determined by some starting point, and the direction is determined by the slope. So let's take a look at how that actually determines a line. Here I have a line. It has a particular position and a particular direction. Notice that as I change the direction of this line, or change its slope, I get a series of different lines. And if I wanted to represent not a line with a different direction, but a line with a different position, I can just take that starting point and move it anywhere on the coordinate plane. Once I have it there, I could change its direction to get another different line. So given any position and any direction, I should be able to determine a unique line. So with that in mind, let's see where the equation comes from. Say I have a line that passes through a point 1, 5 and has a slope of 2. Well, that point 1, 5 is my position, or starting point, and that slope is my direction. So with these two pieces of information, we're going to determine how to write the equation of a line. Well, before I write the equation, I should probably describe what all of the other points on the line are going to look like. Any other point on this line can be represented by the coordinates x and y. And I want to relate this coordinate to the given information. Well, we already have a formula that relates slope to two given points, and that's the slope formula. Slope is change in y over change in x. Well, recall that the change in y is just the difference in the y values, so I could write that as y, my y coordinate of my unknown point, minus the y coordinate of my given point, over x, the x coordinate of my unknown point, minus the x coordinate of my given point. Okay. And I actually know the value of my slope. My slope is 2. So I can say that this is 2 is equal to y minus 5 over x minus 1. If I cross multiply, I end up with y minus 5 is equivalent to 2 times the value x minus 1. This is actually the first form of the equation of a line. This is what's referred to as the point-slope form of a line. The reason it's called the point-slope form of a line is that I can read off a point that's on this line. The coordinates are 1, 5, and the slope, which is 2. So it's called point-slope because I could read off a point that's on this line and a slope that's on this line. In general, this equation can be written in the following way. Given the coordinate of a point that's on the line, x1, y1, and the slope of that line, m, this is what's called the point-slope form of a line. Another form of a line, one that you're probably already familiar from algebra, is the slope-intercept form, which is y equals mx plus b, where b is the y-intercept and m is the slope. Well, that equation of a line didn't come out of nowhere. It actually is derived from this coordinate. And I'll show you that given this information, you can actually solve for something in the slope-intercept form. I'm just going to clear up some of my work. So given the equation that we found in the previous part, I can solve this or change it into the slope-intercept form of a line by solving for y. And I end up with y minus 5 is equal to 2x minus 2, which when I add 5 gives me y is equal to 2x plus 3. This is my slope-intercept form of the line. And it's called the slope-intercept form of the line because I could read off the slope, which in this case is 2. So this is a line that has a slope of 2. And I can read off the y-intercept. So the y-intercept of this line is 3. The last form of a line, which is called the standard form, is written in the following way. The standard form of a line is this ax plus by equals c, where these a, b's, and c's are integer values that are not all equal to 0. So if I wanted to write this in standard form, what I would need to do is bring my value for x over, and I would get negative 2x plus y equals 3. But the standard form has one other caveat. This value for a has to be greater than or equal to 0. So since I have a negative 2 here, what I'll do is take this entire equation and multiply by negative 1, and I end up with 2x minus y is equal to negative 3. So this would be the standard form of the equation of my line. So notice that for any given position in any given direction, there are 3 ways I could write the equation of a line. I have the point slope, where I can read off a point and the slope of the line. I have the slope-intercept, where I can read off the slope and the y-intercept. And I have what's called the standard form. Now, when you would use these 3 different forms, or why 3 different forms are necessary, we'll discuss in class, and we'll also see under what circumstances each of these 3 forms is convenient.